Hello everyone, for our group, we choose Thermodynamics in power industry. Thermodynamics is essentially the study of the flow of the heat into or out of system as it undergoes a physical and chemical transformation. In industry, the thermodynamic system is currently being used. Power industry is one of the industry that use thermal power plant and it is applies law of thermodynamics to generate electricity. The first law of thermodynamics is chemical energy that converted into thermal energy and then converted into mechanical energy and then converted into electrical energy. The second law of thermodynamics is that the processes are irreversible because the entropy increases over time.
Next part is the application part. There are several applications of thermal power plant, which firstly is the extraction steam. Extraction steam is used from a steam turbine to process heat at a plant nearby, such as a paper manufacturer. The second application is that it produces power using waste heat that occurs in processes such as chemical plant that produces heat from a reaction. Waste heat is sent to a waste heat boiler producing steam that is used in a turbine generator set. And the third application is that thermal plant also can burn many different sources and types of fuel, whatever is cheapest and plentiful, even burning trash instead of burying it, which is then the power from the heat is generated. And also, the thermodynamic used in this thermal power plant is the Rankine cycle, which is the cycle works in a way that the heat absorption occurs at high temperature in the gas turbine, and the heat transfer occurs at low temperature in the steam cycle. So, how actually this cycle works? It works through the condensing steam cycle, which is shown as this diagram. So firstly, the fuel is fired in a boiler which converts the heat released from combustion to steam at high pressure and temperature. Generally, the flue gases from the boiler exhaust are at high temperature, and if this heat is not utilized, it will lead to a large number of losses resulting in reduced boiler efficiencies. So generally, this waste heat is recovered by heating either air required for combustion or preheating water before sending it into a boiler. Flue gases are then allowed to pass through a dust collector or bag filter to arrest dust particles so as to prevent air pollution before sending it to the atmosphere. This steam is then expanded through a turbine for generation of electrical power. Exhaust steam from the turbine is condensed in a heat exchanger and then returned via the feed pumps to the boiler. That's all for the application part.
Moving on to the next part, a thermodynamic cycle commonly used in power plants to convert the pressure energy of the steam into mechanical energy through steam turbines is called the Rankine cycle. In a Rankine cycle, it consists of 4 processes in which 2 of them are isobaric processes. The purpose of this cycle is to transform heat into work by using a heat exchanger. Isobaric process is a thermodynamic process in which the pressure remains constant. For the 2 isobaric processes, the first one is isobaric expansion process, or also known as isobaric heat addition. In this process, heat is added in the boiler at constant pressure. When the high pressure liquid enters a boiler, it is heated at constant pressure through an isobaric process by an external heat source until it became a saturated dry steam. In this phase, it changes the phase of water from liquid state to gas state. The second isobaric process is isobaric heat rejection, or known as isobaric compression process. Heat is released from the condenser to the surrounding at constant pressure. The wet steam will enter the condenser and begin to condense at constant pressure to become a saturated liquid. Overall, in Rankine cycle, there are 4 processes involved, which is isentropic compression, isobaric expansion, isentropic expansion, and the last one is isobaric compression. The isentropic principle will be explained in the next part.
Hi, I'm Siti Nuratika binti Muhammad Nasri. Next, I will move to the next processes, which is isentropic. Isentropic process is a thermodynamic process in which the entropy of the fluid or gas remain constant. It means the isentropic process is a special case of an adiabatic process in which there is no transfer of heat or matter. It is a reversible adiabatic process. For the 2 isentropic processes, the first one is isentropic compression. In this process, work is done to compress the working fluid by pump. When the compression work decreases, the tubing work remains the same. The energy used to compress the vapor turns into heat and increases its temperature and enthalpy, so that At the end of compression, the vapor state is in the superheated phase. In this part, the pressure of water increases. The second isentropic process is isentropic expansion. Steam expands and turns the blades of turbine. The turbine will have to handle steam with low quality such as steam with a high moisture constant. The impeachment arisen and is a major source of wear. Thus, steam with qualities less than 90% cannot be tolerated in the operation of power plants. Work is generated and converted into electrical energy. That's all from me.
To summarize, the thermodynamic concept is applied in power plants to generate electricity from primary energy. There are many different types of electric power generating plants, such as hydroelectric, thermal, nuclear, and wind. The power plant can gain energy in an efficient way. There are two processes involved, which are isobaric, a process in which pressure remains constant, and isentropic, a process in which the entropy of the fluid remains constant, this including compression and expansion. The laws of thermodynamics describe how the energy in a system changes and whether the system can perform useful work on its surroundings.